Element 53, that is iodine, on the periodic table of elements. This is Norris Teaches Science with me, Mr. Norris. This is a physical science edition lecture video, and today I am presenting electrical math, which is part of the electricity videos I am making. Now, if you haven't watched the electrical charges and the electrical current videos, I'll go watch these before coming to this one because I'm going to use some of the terms from those videos in today's video. But your goal of the video is I can calculate Ohm's law and electrical power with given data. So let's talk about Ohm's law. What Ohm's law is says voltage in a circuit equals the product of the current and the resistance. Remember, product is multiplication, so we're going to multiply current and resistance. Increasing the voltage will increase the current. Increasing the resistance will decrease the current. So here's algebraically, voltage equals current times resistance, or V equals I times R. The capital V means voltage, V. Capital I means current, and its unit is A, is amps, represented by the A, and the capital R means resistance, and its unit is ohms, which we represent by the omega symbol. So if we take this and we place it into my triangles, remember numbers next to each other are multiplied, numbers on top of each other are divided. Since I and R are being multiplied, so I and R goes next to each other, V is at the top. Let's do two examples. This first example, a wire carries 25 amps of current. If you haven't seen my math videos, I will circle my numbers and I will underline what we're trying to find. 25 amps of current and encounters a resistance of 10 ohms. How much voltage is being supplied to the wire? So the first thing you ask is, what am I trying to find? Well, according to this, it says I'm trying to find voltage. Voltage is represented by the capital V, and in the triangle, the V goes on the top. That means at the bottom goes the other stuff. And one side goes the current. The current is 25 amps. And on the other side is the resistance, which is 10. Now the numbers are next to each other, so we're going to multiply the numbers, and we will get 250 volts, because the unit for voltage is volts. Remember, you need to show your work. Hopefully you get it right, and don't forget about that unit. The unit is very important when doing scientific math. And this will be the answer to problem number 1. I paused the video real quick, use the formula, and try to find out the answer to practice number 2. Did you pause? I hope you paused. All right, here we go. It says a 300 volt battery is attached to a wire that has 100 amps of current. What is the resistance of the wire? So according to this, what are we trying to find? We're trying to find resistance. So we're going to leave R in the triangle. At the top goes our voltage. What's our volt in here? 300. And at the bottom goes our current. Our current is 100. Now numbers are on top of each other, so we're going to divide. And when you enter this in the calculator, you would do 300 divided by 100. But for me, I don't need to do that because I can do this math in my head. So I will get 3E, and then unit for resistance is ohms. 3 ohms. Work, correct answer, unit, full credit. There is a second formula with electrical math, and that is electrical power. I did a whole video about solving for power, but this time we're going to look at power in electrical sense. And it's the rate at which electrical energy is converted to another form of energy. So example of how hair dryers turn electrical energy into thermal energy. That's what it means by electrical power. So let's look at the formula. Algebraically, the formula says electrical power equals current times voltage, or P equals I times V. The capital P means electrical power. Its unit is going to be watts. This is watts. All right, think of like a light bulb. Light bulbs are a certain wattage. A I represents current represented by the unit amps, which we do with A, and V is voltage, and its unit is still volts. Now, if we take our formula, place it in my triangle, remember numbers next to each other have to be multiplied. Numbers on top of each other have to be divided. So since I and V are being multiplied, they have to be at the bottom and P is at the top in the empty spot. Let's do two examples. It says how much power is there when 20 amps of current is in a light bulb that has a voltage of 10 volts. All right, so according to this, we're trying to find power. So we're going to leave the P at the top. Current and voltage, that's what we need. One side's current, and that is 20. The other side is voltage, that's 10. Numbers next to each other, we are going to multiply. 20 times 10, you get 200. And then we still need to give a definition to this number, which means give a unit. And since we're trying to find power, the unit is going to be watts, and that's your answer. So 200 watts of power. All right, pause this video real quick. Try this one. I said pause. You're just like the spider in the corner. It won't, when I said go away, it just continues to stay here. Never mind. Let's go over this. All right, a 90-watt light bulb has a current of 45 amps. What is the voltage of the system? So according to this, we're trying to find voltage, and voltage is V, and we place V right here. All right. At the top goes our power, and that is 90. We know that because of the watts. And the current is 45. We know that because it has the unit amps, plus the question said it was the current. Now, numbers are on top of each other, so we're going to divide the numbers. When you enter this in the calculator, you would do 90 divided by 45, and you would have got 2. We also need to give a unit with this number. Since we're trying to find voltage, the unit is volts. And that is the answer for problem number 2. I hope you learned a little bit about solving these electrical math problems. Most of the formulas are not that hard to learn in physical science. You just need to practice them a little bit more. But I hope you learned something. I'm going to be coming back with another video soon. I'll see you in the next one.